The National Electrical Code, or NEC, Article 110.12 addresses the mechanical execution of work. Conduit fill is addressed in NEC table cone. It is used to determine the maximum number of conductors allowed in a given conduit size based on wire type, insulation, and trade size. To calculate conduit fill, use NEC table cone. For 1-inch conduit and belted multi-pair communication cables, the fill percentage should not exceed 53%. Ensure that the conductor size is sufficient to withstand the mechanical stresses of the installation. For underground installations, a minimum conductor size of 14 AWG is typically recommended. Refer to Belden's specifications for the communication cable to verify the minimum conduit size required. Consider the specific conditions of the installation, such as temperature, humidity, and vibration, which may affect the conduit size selection. Check local building codes and regulations for any additional requirements regarding conduit sizing. To address the contractor's change, firstly, inspect the installation. Verify that the 3/4-inch conduit meets the code requirements for the number and size of conductors installed. Secondly, request calculations. Ask the contractor to provide calculations demonstrating that the conduit fill percentage does not exceed the maximum allowable limit. Thirdly, consult with the manufacturer. Contact Belden or other cable manufacturers to confirm the recommended conduit size for the communication cable. If the installation does not comply with code requirements, consider issuing a violation notice and requiring the contractor to rectify the situation. It's crucial to understand how to apply the National Electrical Code, specifically concerning conduit fill calculations and mechanical execution of work, especially when dealing with installations at remote pumping stations within a water reclamation facility. This knowledge ensures safe and compliant electrical installations. Let's delve into the key aspects. Firstly, we'll explore the relevant codes and standards, primarily focusing on the National Electrical Code. Article 110.12, which is titled Mechanical Execution of Work, emphasizes the importance of neat and workmanlike installations. This means that all electrical work should be performed in a manner that ensures safety and reliability, and any alterations or modifications should maintain the integrity of the original design. Secondly, we will focus on conduit fill calculations. NEC Table C1 is used to determine the maximum number of conductors permitted in a specific conduit size, based on the conductor's type, insulation, and the conduit's trade size. Proper conduit fill is crucial to prevent overheating and potential damage to the conductors. When calculating conduit fill, it's important to adhere to the guidelines provided in the NEC. For instance, if you're using a 1-inch conduit for belt and multi-pair communication cables, the fill percentage should not exceed 53%. This limit ensures adequate space for heat dissipation and facilitates easier pulling of cables. Apart from conduit fill, it's also essential to consider the mechanical strength of the conductors. The conductor size must be sufficient to withstand the mechanical stresses encountered during installation and operation. For underground installations, it's generally recommended to use a minimum conductor size of 14 AWG to ensure durability and prevent damage from physical stress. Other important considerations include referring to the manufacturer's specifications for the communication cable. Belden, or any other cable manufacturer, will specify the minimum conduit size required for their cables. Always consult these specifications to ensure compliance and optimal performance. Installation conditions also play a vital role in conduit size selection. Factors such as temperature, humidity, and vibration can affect the performance and longevity of the electrical system. In environments with high temperatures, for example, it may be necessary to use larger conduits to provide better ventilation and prevent overheating. Local building codes and regulations may impose additional requirements regarding conduit sizing. Always check these local codes to ensure that your installation meets all applicable standards. Now, let's address the scenario where a contractor has changed the conduit size in a run, specifically from 1-inch to 3/4-inch, and has pulled a Belden multi-pair communication cable through it. Firstly, inspect the installation thoroughly. Verify that the 3/4-inch conduit meets all code requirements for the number and size of conductors installed. Pay close attention to the conduit fill percentage to ensure it does not exceed the maximum allowable limit. Secondly, request detailed calculations from the contractor. The contractor should provide calculations demonstrating that the conduit fill percentage remains within the acceptable limits as defined by the NEC. These calculations should take into account the specific type and size of the belt and cable being used. Thirdly, consult with Belden or other relevant cable manufacturers. Contact them to confirm the recommended conduit size for the specific communication cable being used. Their expertise can provide valuable insights and ensure compliance with industry best practices. If the installation does not comply with the NEC or other applicable codes, consider issuing a violation notice. Clearly communicate the deficiencies to the contractor and require them to rectify the situation promptly. This may involve replacing the conduit with the correct size or reducing the number of conductors to meet the code requirements. When evaluating the installation, consider the following detailed aspects. Firstly, NEC Article 300.17, titled Raceway or Cable to Support Suitable for Conductors, requires that raceways, including conduits, be adequately sized to accommodate the conductors without damage to the conductors or their insulation. This article directly relates to the scenario at hand, as reducing the conduit size could potentially damage the conductors during installation or operation. Secondly, NEC Chapter 9, which contains tables and examples for conduit and cable fill, provides the necessary guidelines for determining the appropriate conduit size. Table 4 in this chapter lists the percentage of cross-sectional area of conduit and tubing for conductors. These tables are critical for ensuring that the conduit is not overfilled, which can lead to overheating, insulation damage, and potential fire hazards. The specific type of communication cable being used is critical. Belden multi-pair cables come in various sizes and configurations. The outer diameter of the cable is a key factor in determining the appropriate conduit size. Obtain the exact specifications for the cable from Belden's documentation or website. The cable's diameter will be used in the conduit fill calculations. When performing the conduit fill calculation, use the actual dimensions of the cable, not just the nominal size. The NEC requires that the calculation be based on the actual cross-sectional area of the conductors and cables. This information can typically be found in the manufacturer's data sheets. It's important to understand the difference between different types of conduits. Electrical metallic tubing, or IM, rigid metal conduit, or RMC, and electrical non-metallic tubing, or ENT, each have different properties and applications. The choice of conduit material can affect the allowable fill percentage and the overall installation requirement. Ensure that the conduit material is appropriate for the environment and application. Environmental factors such as temperature and moisture can affect the performance and longevity of the electrical installation. In wet locations, it's essential to use conduits and fittings that are rated for wet environments to prevent corrosion and water damage. High temperatures can also affect the ampacity of conductors, so it may be necessary to adjust the conductor size accordingly. The number of bends in the conduit run can also affect the ease of pulling conductors. The NEC specifies the maximum number of bends allowed in a conduit run between pull points. Exceeding this limit can make it difficult to pull conductors and may damage the insulation. Consider using pull boxes or junction boxes to minimize the number of bends in the run. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes properly supporting and securing conduits, using appropriate fittings, and ensuring that all connections are tight and secure. Sloppy or unprofessional work can lead to safety hazards and code violations. Documentation is crucial for demonstrating compliance with the NEC and other applicable codes. Keep detailed records of all calculations, specifications, and inspections. This documentation can be invaluable in the event of an audit or inspection by regulatory authorities. Regularly review and update your knowledge of the NEC. The code is updated every 3 years, and it's essential to stay current with the latest requirements. Attend training courses, read industry publications, and participate in professional organizations to stay informed. Consider using Conduit fill calculation software or online tools. Several software programs and online tools can simplify the process of calculating Conduit fill and ensuring compliance with the NEC. These tools can save time and reduce the risk of errors. When dealing with communication cables, it's essential to maintain proper separation between power and communication circuits. The NEC specifies minimum separation distances to prevent interference and ensure safety. Follow these guidelines when routing communication cables in the same conduit or raceway as power conductors. Grounding and bonding are critical for ensuring electrical safety. The NEC requires that all metal conduits and enclosures be properly grounded and bonded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and equipment damage. Always use the correct tools and equipment for the job. Using the wrong tools can damage conductors, conduits, and fittings, leading to safety hazards and code violations. Invest in high-quality tools and equipment and ensure that they are properly maintained. Before starting any electrical work, always perform a thorough risk assessment. Identify potential hazards and take steps to mitigate them. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and following lockout/tagout procedures to prevent accidental energization. In addition to the NEC, other codes and standards may apply to the electrical installation, such as local building codes and industry standards. Be aware of all applicable requirements and ensure that the installation complies with all relevant codes and standards. Continuous education and training are essential for staying current with the latest technologies and best practices in the electrical industry. Attend training courses, workshops, and conferences to expand your knowledge and skills. Consider becoming a certified electrician or electrical inspector. Certification demonstrates your competence and commitment to safety and professionalism. Many organizations offer certification programs for electricians and electrical inspectors. Take advantage of these opportunities to advance your career. Communication and collaboration are essential for ensuring a successful electrical installation. Communicate clearly with the contractor, engineer, and other stakeholders to ensure that everyone is on the same page. Work together to resolve any issues or conflicts that may arise. In summary, addressing a contractor's change in conduit size requires a systematic approach. Firstly, verify that the smaller conduit meets code requirements. Secondly, request detailed calculations from the contractor. Thirdly, consult with the cable manufacturer. Finally, take appropriate action based on the findings. By following these steps, you can ensure that the electrical installation is safe, compliant, and reliable. Remember that electrical work should always be performed by qualified and licensed professionals. Attempting to perform electrical work without the necessary training and experience can be dangerous and may violate local codes and regulations. Always prioritize safety and compliance when working with electrical systems.